All right, in this video, we're going to talk about a topic that's kind of like the pinnacle in my mind of Algebra 2, which is equations of quadratic type. All right, so what does this mean? All right, well, first of all, what is a quadratic equation? We've talked about quadratic equations a lot and reviewed them, how to solve them and what they look like. They're ax squared plus bx plus c. So we have this term being squared, then a single x, and then a constant. All right, so that's a quadratic equation. An equation of quadratic type is any equation that's not necessarily a quadratic, but kind of looks like one, and the fact that it has something squared, it has that same thing but not squared, and then it has a constant. All right, so these are equations of quadratic type. All right, so this is an example. Again, there's one benefit in this kind of skill and lesson is that I'm telling you the quadratic type, so you kind of already have an idea of what you're supposed to be doing. If you're out in the wild and then you encounter an equation, it's not necessarily as obvious, but it's still a process even when you know it's the quadratic type. Yeah. All right, so how do I know this quadratic type? Well, first of all, I have something being squared. I have that exact same thing, but not squared. And then I have a constant. All right, so this is quadratic type. It follows that exact same pattern as the top here, something being squared, something not squared, and then a constant. All right, so my kind of first idea is it's quadratic type, so it's like a quadratic. Why not make it exactly a quadratic? So what I'm going to do is replace the complicated thing that's making it not exactly a quadratic by doing a substitution. So I can just make up substitutions, which is kind of a weird thing to do, but I'm a mathematician. I can do what I want. So here it's up to you to pick your favorite letter other than x, because x is already getting used. I will use u. And the reason I use u is because there's something you do in calculus called u substitution. So you substitute with u a lot. That's why it was the first one that came to my mind. Right, but you literally use whatever letter you want other than x, because it doesn't make sense to have x on both sides of this. But if u is x plus 3, I'm going to replace the x plus 3's with u. So now this is u squared plus 3u minus 4 equals 0. And now I've turned this quadratic type equation just into a quadratic. So this is kind of the first step. When you recognize something's quadratic type, you turn it into a quadratic by doing a substitution. And now I kind of ignore the original problem. I'm just going to solve this red problem. All right, you can do the quadratic formula. You can factor. This one you can factor quickly because it's the shortcut method. All right. And then the reason I factor is I can break this up into two separate pieces. And you got u by itself, but you're not done because my original problem was about x, and I just figured out what u is. So now I go back and remember, well, u is actually just a placeholder for x plus 3. Subtract 3, subtract 3. All right, so this is the strategy for solving quadratic type equations. All right, so first of all, recognize then that it follows the pattern of a quadratic. Little useful when you're doing the practice problems because the practice problems are there because they're quadratic type. So one's kind of already done for you. All right, second is you're going to use the substitution to actually turn it into a quadratic. So not a quadratic type, an actual quadratic. So this was the u equals part in our previous step. 3, use your tools to solve the new quadratic equations. This is where we could factor. We do the quadratic formula. If it's appropriate, we can use square roots. Once you solve it, you undo your substitutions. This is when we replace u with x plus 3 again. And then you solve for your final equations. Let's see another example. All right, this one, again, just looking at this, it's not obvious as quadratic type, but we know it is. So let's see why it's quadratic type. 4 to the 2x plus 2 times 4 to the x minus 15. If it's quadratic type, it should be something squared, then that's something not squared, and then a constant. So this is the thing not being squared, this is constant. So how is this being squared? Remember 2x, you can separate this out into two separate exponents that would be multiplied together. So this is 4 to the x squared, this is 4 to the x not squared, and this is the constant. So once we recognize it is quadratic type, we pick our u, and u is always going to be the kind of single thing. So the thing that's being squared, the single thing here, u is 4 to the x. All right, so now my equation becomes u squared plus 2u minus 15. Again, you can do the quadratic formula. You can't do square roots here because of this u here, but you can also factor it, and I'll factor it because this is kind of shortcut method. When there's no number in front of the squared, you can do the shortcut method, and this is u equals -5, and u equals 3. And now I go back and remember, well, I wasn't solving for u, I'm trying to solve for x, so now I have to undo my substitution. 4 raised to the x equals -5. 4 raised to the x equals 3. Right. And now I have to remember, well, how the heck do I solve 4 raised to the x? To get an x out of an exponent, I have to use logs. We learned about logs are the opposites of exponentials. So this is log base 4 of, and then they switch positions. So the -5 goes in here, equals x. Log base 4 of 3 equals x. Right. Another thing we learned about logs, and that's like all year coming together in this one skill, is that you can't put a negative in a log. So this isn't possible, which means this answer doesn't work. But this is possible, so my final answer is just that. All right, so you can see there's a lot to go into this one type of problem. This is why it's one of the very last things you're doing this year. You do your substitution. Now I have to remember, how do I solve quadratics? I can factor to do the quadratic formula. Then I undo my substitution, and now after you've done all of that, now you have to remember how to solve an exponential. All right, and we just talked about how to solve an exponential using logs. All right, here's one for you to try on your own. You can see something being squared, something not being squared. Go ahead and try to solve this one. I'll show you the answer in 3, 2, 1. All right, so recognize the thing that's being squared and the thing by itself is the absolute value of x. That's my u. All right, so my new quadratic with u becomes this. Again, you can use it whatever letter you want. I just use u because it's like a shortcut for substitution in my brain. Whatever letter you like other than x can work. I can factor this one. And then u is 3 and u is 2. All right, so this middle step here is just kind of solving a quadratic the way we've been doing all year. Undo the substitution, replacing u with the absolute value of x. Now I have to remember, how do I solve absolute value equations? I split it up into the positive and negative answers. And that gives me my 4 final answers for this problem. All right, so saying the steps is pretty simple. Substitution, solve a quadratic, solve for x at the end. All right, not very hard to say, but there's a lot going on. You have to recognize the pattern to figure out what u is. You have to do the substitution and remember how to solve quadratics correctly. It's a challenge for some people. And at the end, you're going to have a new type of equation to solve. We have to solve just like a linear equation. Where is it? Here. All right, our final answer part was just a linear equation. It might have to be an exponential equation, a logarithm, absolute value equation. So like the final step you have to do could be different depending on what you started with as well. So there's a lot of little steps in here. But this is why you have your notes, you have the practice time. Trying to review everything. All right, this is like one of the culminating skills of the entire year. All right, if you can do this skill, you are good at Algebra 2. That's basically what the point of this lesson is.